Hello everyone, in today's video we are going to talk about problems involving two inequalities. Did you notice that some of the dots were solid and some were open? Why do you think that is? If the symbol is greater than or less than, then the dot is open and it means that the number is not included. But if the symbol is greater than equal to or less than equal to, then the dot is solid and it means that the number is included. Consider this inequality expression. The number of students in the classroom right now is less than 10. In mathematics, it is x less than 10. But the number of students cannot be negative, so we represent it as x greater than equal to 0. Combining the two inequalities, we have x is greater than equal to 0 but less than 10. To graph x is greater than equal to 0 but less than 10, we are going to use the number line. First, we are going to graph x is greater than equal to 0. So at 0, we are going to use a closed dot or closed circle. Then the direction is to the right. And then graphing x is less than 10. At 10, we are going to use an open dot or an open circle, and the direction is going to the left. So in here, there is an intersection or the two lines overlap. So from here, we can deduce that these are the values that can satisfy the inequality. X is greater than equal to 0 but less than 10. So let us have another one. Let us find where possible the range of values x which satisfy both inequalities. So if we have x is greater than equal to 1 and x is greater than negative 1. So in here, using the number line, at 1 we are going to use a closed dot and then the direction is going to the right. Then x is greater than negative 1. At negative 1, an empty circle or an open dot, and then the direction is going to the right. As you can see, the two lines overlap, so there is an intersection. So we can conclude that x greater than equal to 1 and x is greater than negative 1 are both satisfied by the inequality x is greater than equal to 1, wherein the solution set includes 1 and all other numbers greater than 1, so it is an infinite solution. So let us have another one. Let us grab x is less than equal to 2 and x is greater than negative 2. So in here, using the number line, at 2, we are going to use a closed dot and the direction is going to the left. While x is greater than negative 2, at 2, we are going to use an open dot and the direction is going to the right because it's greater than. And as you can see, there is an overlapping in here. So therefore, both inequalities are satisfied by x is greater than negative 2 but less than equal to 2. So 2 is included in the solution set. Now let us have another one. X is less than 0 or x is greater than equal to 2. So using the number line, at 0 we are going to use an open dot and the direction is going to the left because it is less than, and x is greater than equal to 2. It is a closed dot and the direction is going to the right because of the greater than. So in here, we can deduce that the lines does not overlap and therefore there are no values for x. Now let us solve two inequalities. So let us solve these two inequalities. So first, we are going to solve for x and x minus 3 less than 2x minus 1. So in here, we are going to transpose minus 3 to the other side as well as 2x to the other side. So we will be getting x minus 2x less than negative 1 plus 3. X minus 2x is equal to negative x. And negative 1 plus 3 is equal to positive 2. So to make our x positive, we are going to multiply both sides by negative 1. And by multiplying a negative number to both sides of the inequality, we will be getting the reverse of less than, which is greater than. So the final answer is x greater than negative 2. Now let us solve for the second inequality. 2x minus 1 is less than 5. In here, we are going to transpose minus 1 to the other side. So we will be getting 2x less than 5 plus 1. And 5 plus 1 is 6, dividing both sides by 2. So x is less than 3. Now let us graph x is greater than negative 2 and x is less than 3. So using the number line to graph x is greater than negative 2, at negative 2 we are going to use an open dot and the direction is to the right because it is greater than. And then x is less than 3, at 3 we are going to use an open dot and the direction is going to the left. As you can see, there is an overlapping in there, so therefore the solution is x is greater than negative 2 but less than 3. Negative 2 and 3 are not included in the solution. Now let us have another one. We are going to solve these two inequalities. So we are going to determine x in 3 plus x less than equal to 1. So in here, we are going to transpose 3 to the other side. So it will become 1 minus 3. 1 minus 3 is negative 2. So x is less than equal to negative 2. Now let us have the second one. So 4 minus 2x greater than equal to 0. So in here, we are going to transpose 4 to the other side. So we get negative 2x greater than equal to negative 4. Dividing both sides by negative 2. So in here, we are dividing a negative number to both sides of the inequality. So we will be reversing the symbol. So the final answer would be x is less than equal to 2. Now let us graph. So using the number line, let us graph x is less than equal to negative 2. So at negative 2, we are going to use a closed dot and the direction is going to the left. X is less than equal to 2. At 2, we are going to use a closed dot and the direction is going to the left. So this is the overlapping area. So we can conclude that the solution is x less than equal to negative 2. So all the numbers less than negative 2, including 2, is the solution. Now let us have another one. So let us solve these two inequalities. So first, we are going to have 1 plus 2x less than equal to negative 3. So in here, we are going to transpose 1 to the other side. So we will be getting 2x less than equal to negative 3 minus 1. Negative 3 minus 1 is equal to negative 4. Dividing both sides by 2, we will be getting x is less than equal to negative 2. Whereas 3x minus 5 greater than 1, transpose 5 or minus 5 to the other side, we will be getting 3x greater than 6. Dividing both sides by 3, x is greater than 2. Now let us graph x is less than equal to negative 2 or x is greater than 2. Using the number line, at negative 2, we are going to use a closed dot and the direction is going to the left. While x is greater than 2. At 2, we are going to use an open dot and the direction is going to the left. So as you can see here, based on the graph, there is no overlapping, so therefore the lines does not overlap and there are no values for x. Now let us solve the application in real life. My teacher told me that my mark X in a test is at least 45 and at most 80. Illustrate the inequality on a number line. Take note that the phrase at least in mathematics is greater than equal to. So the first mark is X is greater than equal to 45. While at most, the mathematical symbol for at most is less than equal to. So we have x is less than equal to 80. So if we are going to graph x is greater than equal to 45, at 45 we are going to use a closed dot and the direction is going to the right. While graphing x is less than equal to 80, at 80 we are going to use a closed dot and the direction is going to the right. As you can see, there is an overlapping in here. So we can deduce that the solution is x is greater than equal to 45 but less than equal to 80. And meaning it's all the numbers between 45 and 80, including 45 and 80. So for your practice, please do Wiser Than Me interactive worksheet number 1. So that's all for today, class. Thank you for watching. See you again next time. Bye!